Okay, so the first question says a metal pipe is 77-meter long. Let me draw the pipe. Okay, let me write the question first. Okay, so that you will be able to relate with that. So here the question says a metal pipe is 77-meter long. The inner diameter of a cross section is 4 centimeter. The outer diameter being 4.4 centimeter. Find inner curved surface area. Outer curved surface area and the last one is total surface area. Now when we are talking about pipe, no, it's not the normal cylinder. Once I'm making a cylinder out of it, out of this paper, you can see it's a cylindrical shape, okay, where there is no thickness at this point. If you can see the figure, there is no thickness over here, but if it will be pipe, it will be thicker. Okay, here also you won't be able to see any thickness. Now let me show you a pipe kind of a structure. Can you see this pipe? This one. Can you see my cursor? Can you? Please let me know. I'm talking
Yes,
about this thickness. Can you see the thickness?
yes, ma'am.
It's a hollow pipe. All right. Inner radius is different. You can see it's a smaller circle. Outer radius, it's a bigger circle. That's why two radiuses are given in the question. We have to find the inner curved surface area. Totally fine. We will be using the formula. We also have to find the outer surface area. Totally fine. We will be using the formula. Now, apart from that, we also have to find the total surface area. There we are going to use this concept that there is a thickness. If you here only I'm telling you, look at the structure. Does it look like a ring kind of a structure? At the this one. Let me just focus on my cursor. Can you see it looks like a ring? Circular ring. Can you see? Okay, let's continue. Let's continue and let's solve this question. So this is the difference between my cylinder, which I was showing you with, which I was making with the help of the paper. There was no thickness at all. But here, when we are talking about a pipe, and it is written in the question also that there was a thickness. So we are going to consider that thickness. So that's why in this question, no, you will see that two different dimensions are given, two different measurements are given. What is that? So you can see a metal pipe is this much meter long. That is fine. The inner diameter, inner diameter. What is that inner diameter? This is 4 centimeter. As I have shown you, the inner circle was the smaller circle and the outward circle was the bigger circle. That's why there is a inner diameter and there is a outward diameter. Now what we have to find? We have to find here what is the inner curved surface area. Okay, the inner curved surface area. What is the surface area formula for the cylinder? The surface area formula for the cylinder is 2 pi r h. Do we know radius for the inner one? Yes, we know. Do we know height? Height is same. Whether it is inner diameter, outward diameter, we are talking about the same cylinder. So height is same. So height is already given in the question that our pipe is how much meter long? It is 77 meter long. So height is 77 meter. Easily you will be able to use the formula to find the inner curved surface area. Now what is the outward curved surface area? Again you have to use the same surface area formula. That means 2 pi rh. Here the outward diameter was different, which is given in the question 4.4 centimeter. You will be using radius from there. Height, again the height is same since we are talking about the same cylinder. Now together we will be working on the total surface area. Okay, so the first and second part I am leaving for you. The third part is what? For the third part only I have chosen this question to discuss with you. So total surface area means, if I am drawing a pipe, okay, so here we were having a thickness as well. This is the thickness. So this is the thickness over here. This is the thickness over here, which I have shown to you in the figure itself. Now we will be finding the total surface area. Now total surface area means that green. Total surface area means if you are having a cylinder like this, okay, this area, the outward area, the inner surface area, outward surface area. Due to thickness, we are having two surface area over here, and also that the colored part, the ring surface over here and the ring surface over here. Both the each and every area we will be adding them together and we will be getting the total surface area of the cylinder. What is the total surface area of the cylinder formula? Curved surface area plus this bottom area and the top area. That is the formula for total surface area. But since here due to the thickness we are having two surfaces over here, the inner surface area, the outward surface area, the ring kind of a structure which I have drawn on the board, the green one, upper part green one, downward part green one. Now the inner surface area and the outward surface area you have already found in the first and the second part. You just have to take it from there and you have to add them. What about this green area, both the green area, how you will be finding that? So recall it in the previous class or maybe in the previous any chapter. You have found this green type of surface area formula. Here we are having a circle. Here we are having a circle. So this one area also, if we are having a circle like this, two circles like this, you have already found the area of the shaded portion. If I'm saying this is the shaded portion, you have already learned how to find the area of the shaded portion. How? The area of the bigger circle minus the area of the smaller circle, that will give the area of the shaded portion, right? So area of the bigger circle, how we will be finding? The bigger circle is having diameter 4.4. So diameter of the bigger circle is 4.4. So radius will be 4.4 by 2. That means 2.2 centimeter. And what will be the area of the diameter of the smaller circle? It is given as 4 centimeter. Radius will be 4 over 2. That means 2 centimeter. So the bigger circle is having radius 2.2. The smaller circle is having radius 2. The bigger one is having radius 2.2. And the smaller one, this much, is 2. What we will be doing, we will be, for finding the area of the shaded portion, we will be finding bigger area minus a smaller area. So pi r square, the bigger circle area, minus pi r square, smaller circle area, that will give the area of the shaded portion. So pi capital R means 2.2 square minus pi small r means 2 square. Okay, this way we will be getting the area of the this thicker portion, the colored portion. And if you want to connect with it with the previous shape, this is the green colored part which we are talking about. This area only we are finding. How? By, like, I can show you also. Once you will be having a bigger circle, from that if you will cut down the smaller circle, you will just be having a ring kind of a structure. Okay, so here you will be having pi 2.2 square. From here you will be getting the area. Okay, that area you have to use it here for finding the total surface area. Let me write it. What will be the total surface area? The total surface area will be, area of bigger circle, area of wait, not area of bigger circle. We will be taking the curved surface area of the outward, inner curved surface area, inner curved surface area plus outward curved surface area inner curved surface area plus outward curved surface area plus this upper circle ring and the downward circle ring. So I am going to write 2 times area of the ring, area of circular ring. This way we will be getting the area of the circular ring, that is bigger pi r square, the bigger circle area minus the smaller circle area. How we will be taking this data? This one already we have calculated in the first part. This one already we have calculated in the second part. Okay, and this one is the only thing which we are doing for this part extra. Are you getting it? Please let me know. If you are getting it, I will not do the calculation for you. I will be leaving it for you. And if you are not getting it, we will be doing the calculation as well. Do let me know. Rehab, Zed, everyone is here. Let me check. Just a moment. Yeah, Rumaisha is there. Yatika is there. Are you getting it? What we are talking about?
Yes, ma'am.
Yes, let me know. Is it clear? Anyone to whom it's not clear, please
Yes,
let me know.
ma'am. Clear.
Okay, it's clear. So let's move ahead. All right, you will be able to do it. Only for the third part, you have to work on the area of the circular ring that I have shown you how you will be finding. Because 2 circular rings are there, upper one, bottom one. You will have to multiply whatever area you are getting of the circular ring with 2. Or you can take like the upper one area, and the same you can add again to just add the lower one area. Okay, now let's move ahead. Okay, the next one says the diameter of a roller is 84 centimeter and its length, keep on noting the hints. Okay, then only you will be able to work on these problems, because all the calculation and everything I am going to leave for you only. Length is 120 centimeter. It takes it takes 500 complete revolution to move once over to level a playground. Find the area of the playground. This one is also very simple. Only one trick is there. Okay, here it says that we are having the diameter of a roller. Now how roller looks like? The roller looks like a cylindrical shape. If I will show you a cylindrical shape, let me show you. This is how the cylinder will look like. Okay, a roller. Okay, now here, so we are having a roller like this. Okay, now if you will roll it on any surface, can you see? We are just talking about the curved surface area. The curved surface area. Okay, not this area, not this area, only the curved surface area. When I am just rolling it on the ground, can you see it? So this roller, a roller is there. Obviously the shape of the roller is cylindrical shape, where the diameter of the roller is given and the length of the roller is given. It takes 500 complete revolution to move once over a level of playground. So a playground is like this. A playground is like this. On this one, we are going to move the roller. Okay. Maybe I will be moving on this surface. It will make sense to you. So this way, we are going to roll it. How many times we have to roll it? 500 times we have to roll it, and then we can say over. Okay. We have rolled it completely. Getting it? We are taking a roller, moving it one time curve surface area of the cylinder. Again, second time curve surface area, third time curve surface area. How many times we have rolled it? 500 times we have rolled it, and then we are done with the complete playground. All right. What we have to find over here? We have to find, let's see what the question says. Find the area of the playground. So I'm going to say that area of the playground must be equals to area of the playground must be equals to 500 times curved surface area of the cylinder. Why curved surface area of the cylinder? Because once you are moving a roller, one time complete revolution you will be moving a roller. That means one time curved surface area. How many times you have to roll it completely? 500 times, and then you are done with covering the area of the playground. So how we will be finding the area of the playground? 500 into curved surface area of the cylinder. What is the formula for curved surface area of the cylinder? Again, I am repeating it. It's 2 pi RH. RH, everything is given in the question itself. You just have to do the calculation. Why we are multiplying 500 with it? Because we are rolling it. We are just rolling that circle, that cylinder 500 times. Is it making sense to you? Are you getting it? Let me know. I'm going to move ahead. Okay. I believe you are getting it. Then only I'm moving ahead. If it is not clear, please tell me. I'll take a pause. Let's move ahead. Okay, so we are done with this question. The next one is a cylindrical pillar is this much, diameter this much, Find the cost of painting. I'm leaving that for you. Cost of painting at the rate of this much is given. You just have to find the surface area, curve surface area, and you just have to multiply with the given cost. That question I'm leaving for you. Yeah, this question we will be doing together. Find first the lateral or curved surface area of a closed cylindrical petrol storage tank that is 4.2 centimeter, 4.2 meter in diameter and 4.5 meter high. The next one is how much steel was actually used if 1 by 12 of the steel actually used was wasted in making the tank. Now let's do it. Here what the question says, let's focus on that. Find the lateral or the curved surface area. As I said in the on very first day while explaining the concept, lateral surface means like around it whatever surface area is there. So curved surface area is having one more name, that is lateral surface area. Okay, what we have to find, we have to find the lateral or the curved surface area of a closed cylindrical petrol storage. Again, the cylindrical petrol storage is like this one. We have to find the curved surface area. What information is given? The diameter is given, height is given. What is the formula for curved surface area? It is 2 pi r h. So this basic question I have taken to explain you. No, the first part is very simple. I am leaving this for you. We are going to discuss together the second part. What does the second part says? The first part basically you are just going to find 2 pi r h. That's it, and you will be done. Okay? Just a moment. The first part you are going to just find 2 pi r h. R you know, H you know. Diameter is given, so radius you can easily find. Height is given, everything is given. Now the second part, how much steel was actually used? If 1 by 12 of the steel actually used was wasted. Okay, so let's say a sheet of this much steel was used, actually used steel. What is the that let's say x meter square area of steel is actually used. If 1 by 12 of the steel which is actually used was wasted, you go like when you have to just cover. Yeah, anyone said anything? Please repeat it. Yeah, please repeat it. Am I audible?
Yes, ma'am. No, nothing. I was just asking about the first part. That's it. It got cleared.
It's clear. We just have to find curve surface area, that is 2 pi r. Now the second part says, if this type of storage is there, no, then we are going to buy a steel seat from the market. I just gone to market and bought a steel seat. Suppose this is not paper, this is a steel. Now we are going to wrap it. like this. Okay, so I have bought a steel sheet which I will be wrapping all around it. Okay, now while wrapping, whatever is steel sheet area I have bought from the market, let's say that is x meter square. Out of that, x by 12, 1 by 12 of the whatever I have bought, that means x by 12 is getting wasted. How I am telling that? You read the question carefully. Here it says, if 1 by 12 of the sheet actually used was wasted. So I bought I bought x meter square, that much I am going to use it actually. Out of that, 1 by 12 is wasted. Wasted for what? For the cutting. Cutout portion we also need to exclude. So 1 by 12 part, that means x by 12 part is wasted in making the tank. Okay, let me read what the next what anything else is given in the question. No. So yeah, we just have to find how much steel was used actually if 1 by 12 of this steel actually used was wasted. So we will be taking let's say x meter square of steel I bought from the market. Out of this, how much is wasted? X by 12, this much is wasted. What we have done for the remaining portion? The remaining portion we have taken it to cover the curved surface area of the cylinder, of the cylindrical tank. The cutout portion, just exclude the cutout portion. X I have bought, x by 12 gone to the cutout portion, and from here whatever remaining I have got, that I have utilized for covering the curved surface area of the cylinder is equals to curved surface area of cylinder. Just a second. Okay, so yeah, this question says the lateral or the curved surface area of the cylindrical petrol storage we have to find for the first part, and the second part we are covering the whole cylinder. Okay, if we are covering the whole cylinder, then we will be talking about the curved surface area also, and this bottom also, this bottom also. Okay, since it's a tank, petrol storage tank, as you can see it's a petrol storage tank, so obviously it will not be hollow from here and it will not be hollow from here. Tank must be covered from the back side, and we also have to cover it from the front side also. That is how the tank will look like. Okay, so if you are taking a steel seat and if you are going to wrap it up, you must be wrapping it up from this part also, from the back part also, and from the top part also, like this. Okay, you have to cover it like this. So that means x meter square steel seat I bought from the market. Now out of that, x by 12 gone to the waste cutout portion. Now whatever remaining we are having, that remaining we are going to cover the total surface area of this cylinder. Not only the curved surface area, of course we are going to take the total surface area, because it the question is talking about a tank. If it will be hollow cylinder, then we will not take this portion and this portion. Since it is a solid cylinder where this part must be covered, this part must be covered, hence we have to take the total surface area of the cylinder over here. That much sheet we are utilizing. Okay, so let me write it. X meter square bought from the market, x by 12 gone to the cutout portion, waste portion, and whatever remaining we have got out of x, that is getting utilized to total surface area of the cylindrical tank. Total surface area of petrol tank. What is the formula for total surface area of petrol tank? I have explained the formula, that is curved surface area plus upper circle plus downward circle, that means 2 pi rh plus 2 pi r square. And sometime in your book the formula is also written like 2 pi r in bracket r plus h. So either you can use directly this formula or you can go ahead with the formula. Whatever you are doing, it's fine. So x meter square you have bought, x by 12 gone to waste. From here you have to find the value of x, that how much you bought from the market. That much seat is utilized, that much seat you need. Actually you need that much seat only, because if you will buy less than x, if you will not consider the cutout portion, then you will just while wrapping it up you will feel that there is a like some portion will left without wrapping. So you need to consider about the cutout portion also. Okay, so 12x minus here, if you don't know how to work with this calculation, here x is there minus x by 12 is there, so here the denominator is 1. 1 and 12, you will find the LCM. LCM of 1 and 12 is 12 only. Okay, here 1 is there, so 1 multiplied with 12 became 12. So here also you need to multiply 12, it will be 12x minus x. Here you will be having 11x by 12 is equals to this. This we know already radius, we know already height. We can just compare it and we can find the value of x. And here we have to find the value of x only, how much meter square, how much steel was actually used. That means how much steel you bought from the market, how much you have taken from the market, that much is used. Okay, is it clear to everyone?
Yes, ma'am.
Okay, so if you want to note down the hints, please note it down. And this is how we will be working on this problem. Now the next question. I'm moving to the next problem. Let's move ahead. I'm going to finish this chapter today only. So the next one also I'll be giving the hint and will be leaving it for you. A lamp shade is there. It is to be covered with a decorative cloth. We have to cover this lampshade with a decorative cloth. Okay. The frame has a base diameter. The base diameter or this diameter all are same only. This is given as 20 centimeter. And the height is already given as 30 centimeter. A margin of 2.5 centimeter is to be given for folding it over the top and the bottom. So a margin, let me write this statement. A margin of 2.5 centimeter is to be given for folding it over the top and bottom of the frame. Now how much cloth required? Required for covering the lampshade. Again, to cover the lampshade means you are going to cover the total surface area of the lampshade. Okay, now here one twist is there only, that a margin of 2.5. So here also You need 2.5 extra. Here also you will need 2.5 extra. So that you can fold it. Later on you can fold it and you can wrap it properly. Okay. So we have to find the total cloth required for covering the lampshade. We are having a cylinder, radius is given, height is given. A margin of 2.5 we need from the top side, a margin of 2.5 we need from the bottom portion. How much cloth is required? So whatever cloth is required, that must be having this height. This height. Rather than the height of the cylinder, we have to take in consideration this height, because this much height must the cloth, this much the height of the cloth must be this much only. From the upper side 2.5 extra, from the lower side 2.5 extra, so that we can wrap it up later on. Okay. So instead of taking height of the cylinder over here as a 30 centimeter, you will be taking height of the cylinder as a height of cylinder you need to take over here as a 30 plus 2.5 from the top plus 2.5 from the bottom. That means 30 plus 5, that is 35 centimeter. This height you will be using while finding the total surface area of the cylinder. What is the formula for total surface area of the cylinder? Total surface area of the cylinder formula in your book, it is directly, it must be written as 2 pi r in bracket r plus h. How we got this formula? We got this formula from here only. So either you can go ahead with the help of total surface area formula, that means curved surface plus upper circle plus downward circle, or you can directly use this formula 2 pi r in bracket r plus h. R we already know since diameter is given, but h is also given. That height we are not going to use over here. We are going to use this height over here because of the margin required. Okay. Since we want to cover the total cylindrical part, hence we have to find the total surface area. We don't only want to cover the curved surface area, we also want to cover the top part and the bottom part. That's why we are talking about the total surface area of the cylinder. Clear? Is it clear?
Yes, ma'am.
Let's move ahead. The last question from today's topic. Do it, and in the next class, do let me know whether you were able to finish all the questions by yourself or not. Once you will work on it by yourself, then only you will be able to understand whether exactly you are understanding the concept or not. So the next question says the student of Vidyalaya were asked to participate in a competition. Okay, the students of a Vidyalaya were asked to participate in a competition for making and decorating pen holders in the shape of cylinder with base using cardboard. Each pen holder was to be of radius 3 centimeter and height 10.5 centimeter. The Vidyalaya was to supply the competitor with cardboard. If there were 35 competitors, how much cardboard was required to be bought for the competition? Now let me tell you the whole story. Okay, there was a competition in a school. The way, like you have seen a lot of competition in your school, like that there was a competition. What was the competition? The competition consists of like decorating pen holder or making a pen holder. How exactly the pen holder looks like? It's in shape of cylinder. Let me draw it. It's in shape of cylinder. Now if you have seen a pen holder, you can understand that that cylinder must be having the base covered, but the top part will be open. From there we can put the pen, right? But the base has to be covered, because if it will be open from the bottom part, the pen will fall, right? So this is the shape of the pen holder. There are uh, that is what the this competition is all about. Everyone have to make a pen holder. Now let's read it carefully. The competition for making and decorating pen holder. Of course, in the shape of cylinder, each pen holder was to be of radius. Each pen holder was to be of radius given, height given. What is the radius of the pen holder? What is the height of the pen holder? That is already provided, the information that you have to take the radius and height, this measurement only. Okay. Now it is the responsibility of the Vidyalaya. The Vidyalaya was to supply the competitors with the cardboard. Who will provide the cardboard? Are they going to bring it from their home? No. Vidyalaya or the school will provide the cardboard to each and every competitors. How many competitors were there? 35 competitors are going to participate. So for 35 competitors, they are going to obviously provide cardboard to each and every competitor. How many pen holder they will make? They will make 35 pen holder, because 35 competitors are there. So each and every competitor will make one pen holder. And how many pen holder they are going to make total? In total, 35 pen holder they are going to make in total. Okay. For making 35 pen holders, how how much cardboard was required? How much cardboard was required? How much cardboard the school will buy from the market, so that they can provide it to 35 competitors, so that 35 will make 35 pen holder. Now what is the dimension measurement of the pen holder? You know that this is how the pen holder looks like. Here the height is given as a 10.5, and what else? Radius is given as 3 centimeter. But which surface area we will be finding here? The curved surface area, the total surface area, which surface area? Anyone from here? Please let me know which surface area you are going to find. If you have to find the surface area of this one pen holder, then are you going to find the curved surface area, or you are going to find the total surface area?
Third surface area?
Curved surface area means this much. The curved part. The curved part. But this is hollow. This is hollow. And if I will put a pin, it will fall. So only the curve
Okay.
surface area will
No,
work.
ma'am. No, total surface area.
If we are finding the total surface area, that means it is covered from the upside also and from the
And
downside also,
also. Okay.
like this. Now from where you will put the pin? You will be finding, Yatika, you will be finding the curve surface area and only one of the circle base area. The top one will be open, right?
Right.
This is how the pin holder looks like, right?
Right.
So the curved surface area formula is 2 pi RH, and the bottom area also you have to take in consideration, that is pi r square. It's a circle. Okay, a circular lid you are going to paste over here. Getting?
Yes, ma'am.
For one pin holder area, how much sheet will be needed? 2 pi RH plus pi r square for one pin holder. Okay. So for one pain holder will require 2 pi RH plus pi r square. This much area. This much you will be calculating with the help of the given data. R is given, H is given, everything is given. We need to find it for 35 pen holder. Cardboard require will be whatever you have got from here calculation, this multiplied with 35. That will be the total cardboard the school, the Vidyalaya will bring from the market. Clear? Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
So just take the hint, do solve all the question and do let me know in the next class whether you were able to do it or not. I'm keeping it this much. If you want to ask anything from here, from any of the question, please do ask.